of relations and functions. Before you've looked at, and the reason for this is you have situations where maybe you have a formula for how many shoes you sell to make a profit, and then the question might be, well, how much profit do you want to make, so you need to determine how many shoes you need to sell. And we would use the inverse operations for that. So types of inverses that you've looked at before is the additive inverse. So the inverse of 3 is negative 3. Those are additive inverses because they're opposites. If I add them together, I get 0. Multiplicative inverse, if I multiply two numbers together, then they equal 1. That would be the multiplicative inverse, like 5 and 1/5, or 2/3 and 3/2. You might have looked at the multiplicative inverse for matrices. All right? We might have done a little bit of that. So you can also find and apply inverses to relations and functions. To graph an inverse, we can reflect each point across the line y equals x. So what that means is that we are going to switch the values of x and y in each ordered pair. So inverses, the main part of inverses is that we're just going to be switching x and y. Okay? So if you keep that in mind, it makes it a lot easier. Okay? So we're going to look at finding inverses of just points, and then we're going to actually use functions and find inverses of functions. And when we get to the functions, I'm going to show you how your calculator or that app that you now have, that if you put it on your phone, that will help you to visualize it to help you do it. All right? So first of all, we're going to look at some points and finding the inverse for points and domain and range. So here we have 5 points. Okay? And we want to graph those 5 points. So I know you've got notebook paper. If you want to get graph paper and do it so it's more accurate, you could do that. So we're going to graph these 5 points on our paper first of all. Right? 0, 2, 1, 5, 5, 6, and 8, 9. Actually, excuse me, there's 4 points. So I'm going to start out and just graph them. 0, 2. There we go. 1, 5. 5, 6. And 8, 9. And after you graph them on your paper, we want to connect them. All right? So we're going to actually connect them. Right, so once you've got them graphed and connected, we're going to find the domain and the range. And we're going to use the actual connected points for doing this. So domain is your x value. So when they ask you for domain, you want to go, okay, so what's my smallest x value and my biggest x value? And we're talking about everything in between them then. All right? Because it starts at one spot, they're connected all the way to the last one. All right? So what's the smallest x value here? 0. Okay, 0, and the largest one is 8. So we'll say that x is greater than or equal to 0, less than or equal to 8. And remember that domain is always x values. And the range then is the y value. So do the same thing. What's the smallest y value? And the largest one is? So we'll say that y is greater than or equal to the smallest y value, 2, less than or equal to the largest one, 9. Okay. So there's just taking that relation that they've given us, graph it, find the domain and range. So to do the inverse then, all the inverse is a reflection over the line y equals x, which means that all we're going to do is take the values of x and y and switch them. So when I write down my inverse, take all those points, switch them. So the first one was 0, 2, so that becomes 2, 0. 1, 5 is 5, 1. 5, 6 is 6, 5, and then 9, 8. So for the inverse, all we're doing is switching x and y, and so we'll plot those points. 0, 2, 5, 1, 6, 5, and 9, 8. And then connect them. And so there we've graphed the function, the relation, and the inverse. Now the one thing to notice is that if they are inverses, then when I graph the line y equals x, then all of those points that are inverses are actually perpendicular to the line y equals x. Okay. So if I connected, let's say I connected these two together, right, they are perpendicular to the line y equals x, and they're both the same distance from the line y equals x. Right? So if you've done it correctly, then they're going to be the same distance from this line, and they'll be perpendicular to the line. Right? So the domain and range then for the inverse. Well, what did we do? Okay, we just switched x and y, right? So if we just switched x and y, then the domain and range are just going to switch also. Okay? So the domain for this is x is greater than or equal to 2, less than or equal to 9. And the range, y then, is greater than or equal to 0, less than or equal to 8. So inverses, just a matter of switching x and y, which means that the domains and ranges are going to switch also. When a relation is also a function, you can write the inverse in function notation. So we're going to use this notation for the inverse of a function. Right? So we'll say f inverse of x is how you read that. Even though it shows a -1 there, that means f inverse of x. So for instance, if I put the number 3 in for x in the function x plus 6, I'll get 9 out. So for then the inverse, if I put 9 in to the inverse, then 3 will come out. So you notice here that the function they show is x plus 6. The inverse is x minus 6. So when I think of inverses, I kind of think of it this way, that when I get dressed in the morning, I put on shoes and socks. Right? So first I put on my socks, and then I put on my shoes, right? Okay, most people do it that way anyway. Okay. So when I get home and I take them off, what comes off first? Okay, your shoes and then your socks. All right. So when we're finding inverses, we're basically just doing inverse operations the same way you've done them all along. All right. So if you're solving an equation, all right, when I want to move 6 from one side to the other side, what do I have to do to it?
Do the opposite.
Okay, you do the opposite. So if it says plus 6, I'm going to subtract 6. Okay? If it says multiplying by 3, I'm going to divide by 3. And that's all that is doing inverse operations. You've been doing it for a long time. It just, you haven't really called it that or talked about it that way. All right? So here we've got using inverse operations to write the inverse of f of x equals x minus 1/2. So we'll say f inverse of x equals, all right, and what is the inverse operation of subtracting 1/2? Okay, adding 1/2. So the inverse of x minus 1/2 would just be x plus 1/2. And yes, it's that simple. Okay. All right. All right, so let's just do these while I'm here. 2a, f inverse of x. It says f of x equals x divided by 3. Okay. The fraction x over 3 is x divided by 3. Cooper, what's the opposite of dividing by 3? Multiplying by 3. So the inverse would be 3 times x. Okay. So when you have the most simplest of operations for inverses, if all there is one thing going on, you just need to think about what's the opposite of that. What's the inverse thing of that? Okay. So for letter B, what's the inverse of x plus 2/3? Danae? X minus 2/3. So if all there is one operation going on, you just think about, okay, what's the opposite of that thing? Okay? Okay, that's great. That works well. All right? So, if we add a little bit to that then, we're still going to do the same thing. Okay? Thinking about inverses is that what we can do is just switch x and y and solve for y. Okay? And so all this is let's think of it this way. Right? That this function they've given us is basically this. Y equals 3 times the quantity x minus 7. Okay? Now I'm going to change it just for a second to help you out. I'm going to make this 6 equals 3 times x minus 7. Okay? And so I want you to think about what would you do to solve for x there? What's the first thing that we would do? Barrett, what would you do first?
Divide by 3.
Divide by 3. Okay? So we'll divide by 3. So we get 2 equals x minus 7. Megan, what would you do now? Add 7. So we get x equals 2 plus 7 is 9. Okay. So all this is doing things that you've done for a long time. The only thing is when we're done, we're going to have a variable in our answer then. Right? So we are going to switch x and y. So we're going to write as x equals 3 times y minus 7. And just like we solved for x here on this right-hand side, we're just going to solve this for y. Now the only thing is that for some of you, you have to remember that you can only add like terms together. So when it gets to that point, make sure you don't add 3x and 7. Right? You can't do that. Okay? So what did we do first? We divided by 3. So we'll divide by 3. So we get x over 3 equals y minus 7. Then what did we do over here? We added 7. So we're going to add 7 again. So we get y equals x over 3 plus 7. Okay? The only thing is that this is a function, so we're actually going to write it as f inverse of x equals x over 3 plus 7. All right, and you must use this notation. So we're not going to leave it as y equals. We're going to change it so it's f inverse of x equals. All right. So let's look at this with this nice little app here. All right, so I'm going to graph y equals 3 times x minus 7. Okay. So here's the graph. It's a soap dispenser. They're trying to kill it. Okay, yeah. All right. So here's the function, y equals 3 times the quantity x minus 7. So what do we say the inverse is? What do? Switch x and y, right? Okay. So I'm going to switch x and y. So here is the inverse of that function. Right? And so here's the one thing your calculator will not do. All right? It will if you solve for x. Okay? Or solve for y. Switch them and solve for y. But you can just type them in here to verify that you have the right thing. Okay. And so if I actually graph these on my paper, I could check to see if what? The points work, right? Okay. Because what do we got? Here is the point negative 20, 0. Point on the other graph should be 0, negative 20. Actually, I think it's probably at 21, but it's close. Okay. Let's see. Yep, negative 21, 0, 0, negative 21. Okay. As long as those are on the opposites, then you're all good. Okay. Here we have 7, 0, so this should be 0, 7. Those are inverses. So you could check to see if you get the same points here then, all right, with your version that you've solved for. All right? So let's look at another one. Here they actually want us to graph it, then write and graph the inverse on the same thing. Okay. So how do I graph negative 1/2 x minus 5? Well, when you graph, you do what first? If it's a line. Hopefully the y-intercept first, right? Okay, graph, we would graph the negative 5, and then negative 1/2 tells us we do what?
Go up 1, 2.
Go down 1 for the negative 1 and to the right 2. So we've got y-intercept is at negative 5. Let me move my graph a little bit here. And so we're going to go down 1 over 2, and we can draw that line. Okay. So here's the thing. Okay, when I'm all done, And this makes this easy. Right? I've got the point 0, negative 5, right? Okay, the y-intercept. And I also have the point 2, negative 6. So what point should my inverse have then?
Negative 5, 0.
Okay. So when I find the inverse, I should have negative 5. 0 should be on that line, and negative 6, 2. Oh, all right. So I can go ahead and draw them. I can draw that already. All right. Let's see. Negative 5, 0, and negative 6, 2. And then I can draw the line through those 2 points. So here's my inverse. Now, here's one thing, okay? What should be true about that point where those 2 lines cross? What should be true about that point? Let's go back over here for a second. All right. Let me get rid of these for a second. Okay. These 2 lines cross at one point, right? Anybody know what's going to be true about that point before I even touch on it so you can see it? Okay. So remember, we're talking about the reflection over the line y equals x. Okay? So we said that this point here and this point here, x and y is switched, right? Okay. This point here is on both of those lines, isn't it? So then what must be true? If they're on both the lines, then if I switch a number and get the same number, right? So these actually, the point where they intersect is going to be x and y are going to be equal because these are on the line y equals x. So the point where they intersect should be on that line y equals x. So over here then, this point here where they intersect has to have the exact same x and y value. If they don't, then you made a mistake, okay, on that graphing. All right. So here we've graphed our line, we've graphed our inverse just by taking 2 points and switching them, drawing the line. All right. Now let's actually switch x and y. Oops. And find the rule for that line. Okay. So we switched x and y, we're going to solve for y. Nick, what do I do first? Do I get rid of the 5 first or the 1/2?
Get rid of 1/2 first.
Okay. All right. We're going to get rid of the 5 first. All right. If we put a number over here, okay. Remember, if we put a number over here, we would add 5 first, and then we're going to get rid of the 1/2. Okay. So we'll add 5. So just remember, this is x plus 5, not 5x. So how do I get rid of that negative 1/2? What do we do? Divide by negative 1/2, okay? Except I don't like dividing by fractions. So what should we do if it's a fraction, though? Okay, nope. Multiply by the reciprocal. So we're going to multiply both sides by negative 2 over 1. Right? Because negative 1/2 times negative 2 is positive 1. So we get y equals negative 2x minus 10. All right, and I can see my graph was a little bit off just because of my graphing capabilities sometimes. Because the y-intercept should be a negative 10. It's pretty close. Slope of negative 2x. So this is f inverse of x. Make sure you write it as f inverse of x. All right, so let's see what happens here. So if I put in here, and I'm going to change it here, y equals negative 2x minus 10. I better get rid of these other two, right, because they were the wrong ones. And y equals negative 1/2 x. Oops. What was it? Minus 5, right? Let's zoom in a little bit here. Okay. So let's check our points. 0, negative 5, negative 5, 0. Negative 10, 0, 0, negative 10. Right? If they match, I did it right. Okay, and you can obviously you can do that on your calculator. It's just nice seeing it here also. Okay. Any questions on them then? So we are to solve a function or find the inverse of the function, we just switch x and y and solve for y. All right, so we got one more question to answer. Okay, nice application problem. Juan buys a CD online for 20% off the list price. He has to pay $2.50 for shipping, so the total charge is $13.70. What is the list price of the CD? So we got an equation here. He buys a CD for 20% off the list price. How do I represent 20% off the list price? And we're not going to use 0.2. Okay, good try. What? Kyle? What do we do? No. There? Nope.
0.8.
0.8 is the number we're using. Okay, why is it 0.8 then?
Because that's 80% of the price if it's 20% off.
Yep, it's 20% off, so I'm paying 80% of the price. So the cost is equal to 80% of the price of the item, and then what did we have to do? Okay, so we had to pay shipping of $2.50, and that's going to equal $13.70. So you gotta always remember with percents, okay? Everything starts with 100%. All right, and that's where, when we were working with yesterday with the growth and decay, right? We started 100%. If it's a discount or it's a decay, we take that away from 100% to give us the actual percent we're going to use. If it's growth, then we add that to 100%. So where this says it's a discount of 20%, I'm talking about only paying 80% of that. Okay? So then it's just a matter of solving this equation. Okay. Anybody do it yet? Eric, what'd you get? Okay, so the list price is $14. Subtract 250, divide by 0.8. And you could Use your calculator to do that too, for the more difficult ones.